Hello everyone. So in today's video we're going to be learning about 1-2. So it's 1-2 and page number 11. Okay. So in this section we're going to be learning about all different type of angle relationships. And few examples on similar triangles. So similar triangles. I'll start off with angle relationships. So the first type of angle you needed to know is called vertical angle. So vertical angles, how does these angle actually kind of like, how do they look like? So let me start off with that. So anytime we have two lines intersecting like this, and exactly at the intersection point, which is this, so the angle on opposite sides always are called vertical angles. So let's say angle 1 and angle 2. So these angles always going to be equal. So vertical angles are always equal or congruent. So angle 1 would be congruent to angle 2, and angle 3 would be congruent to angle 4. That's the property for vertical angles. Vertical angles always the same. Now next type is when you have two parallel lines with a transversal. So when I say transversal, basically it's just a line that passes through two parallel lines. For that kind of scenario, we have four different type of angles. So the first one is called alternate interior angles. Now trust me, you don't have to memorize anything. If you could actually understand the name, that would be more than enough to understand the angle at the same time. So if I say alternate and it's interior, so basically the two angles on the opposite side, when I say alternate means those angles can be on the opposite side. And when I say interior means those angles are inside two parallel lines. So let me label these. So let's say, okay, this is my first parallel line, this is the second one, right? So those angles has to be inside these, means I'm talking about this inside part here. So but on the opposite side, so angle 1 here would be equal to angle 2. And angle, let's just say this is also inside angle, and that would be congruent to 4 because it has to be on the alternate sides. So I have angle 4 congruent to angle 3. All right, so they are always equal. Now the next one is alternate exterior angles. Again, just like the last one. Now I have two angles on the opposite side, like alternate side, but it's not inside two parallel lines. Instead, it's outside parallel lines. So this time I would look at, this is, let's say 5, and the angle on alternate side outside the lines would be down here, which is 6. So I would say angle 5 would be equal to angle 6. Do we have any other pair? So I would just say this is 7, that would be congruent to angle 8. So 7 and 8 would be the same. Next one. Next type is called corresponding angles. Corresponding. So pretty much clear from the name, when I say corresponding angles, means the angles at the same position. If one is on the right side above the line, other one has to be at the same position, like above the line on the right side. So those type of angles are also equal. So like if I look at this shape here, so angle 7 matches up with angle 3. So angle 7 would be equal to angle 3. Why? Because both are on top of the line and on the right side of this transversal. Do we see any other example? I could have angle 1 and angle 6. Again, both under the line and on the right side. Or we have multiple options, 4 and 8. Then I have 5 and 2. Then I have, pretty much those type, So that's called corresponding angle. Now the last one is called, some people call these consecutive angle, or I'm just going to put consecutive. Consecutive angles. It means angles, those are next to each other, right? So if I take you back to, or I can just draw another one. So let's say it's 1, 2, 3, 4, 5, 6, and 7, 8 here. So pretty much next side, like angles next to each other. So I know 3 and 2, 3 and 4, 5 and 7, 6 and 1, 8 and 7. So pretty much next to each other, those angles are always going to be supplementary. So some consecutive angles are always supplementary. So from this one, I can say angle 4 plus angle 1 would be equal to 180. Same for 4 plus 5 would also be equal to 180. And 5, 6. So again, there are multiple options here. So angle 5 plus angle 6 would also be 180. As long as those angles are next to each other, those will be always supplementary. So these 4 types of angles you needed to know first. Now let me show you an example and then we'll move on to our next part. So I have 2 parallel lines and here's the transversal. This angle is 3x plus 2 degrees. This angle 2 is missing. This angle 3 is missing. And 4, which is down here, it's equal to some expression as 5x minus 40 degrees. Okay, that's all I know. So I have to solve for the missing variable and then missing angles. So let me start off with finding some relationship between this angle and this angle. Both angles are outside 2 parallel lines, so definitely, and it's on alternate side, means definitely going to be alternate exterior angle. And what's the property? So those angles are always the same, so I would set this up like this. 3x plus 2 would be equal to 5x minus 40. Okay, now that's just an equation. I'll solve for x, combine like terms, take away 3x both sides. This becomes 2x. I would add 40 both sides, add 40. So this becomes 42 and it's equal to 2x and x would be equal to 21. But that's not my angle. So you have to plug this number back into each expression. So 3 times 21 plus 2, this would be 65. So if that angle is 65, this would also be 65 degrees. Okay, we already know these angles. Let me take away this piece here and put this 65 instead. Okay. Now, do we see any other relationship? I see angle 3 is its vertical angle. So it means if this angle is 65, this would also be 65. Okay, angle 2. So 3 and 2, isn't it? Those angles are consecutive angles just side by side. So those angles are always supplementary. So I know angle 3 plus angle 2 would be equal to 180 degrees. So since I already know angle 3 is 65 degrees, let's just say this is still angle 2 which is missing. I would just take away 65 both sides, so I know angle 2 would be 105 degrees. Here you go. So that's how we solve for missing angles. Okay, now that was all about this example. Now let's move on to a few more relationships and few theorems, I would say. Okay, next one is it's about a triangle. So all 3 angles of a triangle add up to 180 degrees. So let's say this is angle 1, angle 2, and angle 3. So angle 1 added to angle 2 added to angle 3 would be equal to 180 degrees. Anytime you know at least 2 angles of a triangle, you could always solve for the third one by adding the ones you know and take away from 180 degrees. So that's how we solve for the missing one. Now next one. So this is called kind of like outside angle theorem. So let's say you have a triangle like this. You have one angle. Let me use a different color. So you have my first angle here, my second angle here, third one here, and this is the fourth one. Okay, so in order to understand this theorem, I'm actually going to show you something first, and then I hope that will help you understanding the pattern. So how about if I say angle 1 added to angle 2 and added to angle 3 is equal to 180 degrees. Yeah, that's true. Why? Because it's a triangle, right? 1, 2, 3, all 3 angles from a triangle add up to 180. So we got that part, right? Now, if I ask you to look at this straight line here, isn't it a straight angle? Right? So straight angle means it's always 180 degrees. So those 2 angles can be supplementary. So if I say angle 4 added to angle 3, which is inside the triangle, isn't it that would also make 180 degrees if you add? Now try understanding the pattern. So what I see is, it's basically angle 3 is kind of like the same piece that goes into both equation. That makes 180 degrees in both, right? So from this equation, I could say that this whole piece, the sum of first and second angle in this triangle would always be equal to this outside angle, which is angle 4. So it means these two would always add up to this outside angle. Why? Because they both share that tiny piece of angle 3 in there, and both makes 180 if you add it at the end. So that's the outside angle theorem. So two inside angles of a triangle would always, sum of two angles, inside angles of a triangle would always be equal to one outside angle. All right? So let me show you an example. Let's say, I'm going to show you two different ones. Let's say I have a triangle here. This is 10. Let's just say this is 70 and find the third angle. Can we do that? So I could just add 70 to this 10 degrees, and I would pretend the last one is x. So for x, so add these two, and x would be equal to 100 degrees at the end. So what if you have something like this? This is, let's say, 70, and this is x, and this is, let's just say 30. All right. And these two angles, I have to solve for x and y both. So since by the last property we just finished here, I know the inside angle, which is 70 plus 30, would always equal to one outside angle. So what would be that? So this would be 100 degrees. So angle y is equal to 100. So from there, I could solve for x because that's going to be a supplementary angle. So I know the angle x would be equal to 80 degrees. So that's how we deal with outside angle theorem. Okay, so the next one is, it's about type of triangles. So we're going to be learning about classifying triangles. How do we classify triangles? Based of angles and side lengths. Let me start off with angles first. If all angles are acute, then it's called acute triangle. If one right angle, like this, it's one right angle, it's called a right triangle. And the last one is, if one angle is obtuse, something like this, then it's called obtuse triangle. That's how we classify based off angles. Now, other one is based off side lengths. So based off side lengths. So if all three sides the same, it means it's called equilateral. Equilateral triangle. If two sides are the same, it's called isosceles. The last one is if all three sides are different, then this is called scalene triangle. So that's how we classify triangle. Okay, so next one is similar triangles. Okay, so first of all, let's try understanding what it means by similar triangle. So basically what happens is, so size, okay, so basically what's going to happen is the shape always going to look the same, but size going to be different. Like let's say I have big right triangle here, and there's a small right triangle. These are similar triangles. Why? Because they look exactly the same. They both are right triangle, but their shape, their size is different. That's called similar triangle. So keep in mind, anytime similar triangles, angles always going to be, angles always the same, but the side lengths always gonna be proportional. So the side lengths always going to be always proportional. Means the ratio always going to be the same. So let me show you an example. So like first one here. So here's my first triangle, and here's the second one. Okay, so let's say if this one is 45 degrees, this one is missing, this one is also missing. But I know it's similar triangle. This one is 104 degrees, and this one is 31 degrees. Okay, based off this information, can we solve for the missing ones here? So how about, since I already know both are similar triangles, their angles always going to be the same. So first angle up here, since if this is 45, this would also be 45, okay? How about the angle with two lines here? If this is 144, since this angle is its corresponding angle, that would also be 144. And the last part, 31, if that's 31, its corresponding angle also is going to be 31 degrees. Now, let me show you how to deal with side length. So let's say this triangle is 16, 24, 32, and it's similar triangle. It's not a right triangle, kind of like this is 8, this is missing, and this is missing. Okay, there are two different ways you can actually deal with this type of problem. First, you can find their scale factor. If you could find the scale factor of these side lengths, that would be way easier. If not, then I'm still going to show you another way. Okay, what I see is, let's look at one pair of corresponding sides. I see this side is 16 and its corresponding side is 8 in the other one here. So what's their scale factor? So the bigger one is actually twice a smaller one, right? So scale factor is 2. That's the first thing you could do. So scale factor is 2. If this is 16, this is 8. If this is 24, so the other side would be half of that, which is 12. If this is 32, so you know this is definitely going to be 16 here. So that's one way to do it. If you don't want to do it, because you know every time it's not going to be easy to find scale factor, right? So another thing you could do is you can set up a ratio. You can set up a ratio. How would you do it? So again, for setting up ratio, we have two different ways. I'm going to show you both, and either ways it's going to be the same thing. So first way is like you can set up a fraction from the one triangle, set up equal to same corresponding side fraction on the other side. Like let's say if I take this side from my bigger triangle and put it over this base side from the bigger triangle. Let's set it up equal to same corresponding sides from the smaller triangle. So I would do 8 over the base side, which is x. And from there, just do cross product. So cross product like this. So 16x is equal to 24 times 8 is 192. And if you solve for x, this is going to be 12. Here you go. So we figured this out. All right. Or if you don't want to do this, you could do another way, like here. I would take this side from the bigger triangle and put it over its corresponding side from the smaller triangle, which is 8. Do same thing for the other one. Okay, I would take this side, 24 from the bigger one, and its corresponding from the smaller one, which is x. And then just do cross product from there. 16x, 192. And x is equal to 12. So either ways it's going to be the same thing. You could do either both sides from one triangle, set it equal to its corresponding sides from the other, and then cross product. Or find the scale factor. So either or. And yeah, I'm almost done. One last example for that. I need to show you a picture here. So picture of an example that's already in your, no, pulled up, no, my bad. Let's just do, here you go, this one here, and done. Okay, so for this one here, so it's a kind of fire station, and need to measure the height of the station flagpole. So we are trying to find height of this flagpole. And this fire station and this kind of shape, both are similar triangles, so I know both sides going to be proportional. So they find that at the instant when the shadow of the station is 18 meter long, so the station, this is the station, and the shadow is 18 meter long. Fire station itself is 10 meter, the height is 10 meter, and the flagpole's shadow is 99 meter long. And okay, what else? Find the height of the flagpole, which is this side here. So first thing, since I know both are similar triangles, what I would do is, okay, since if you look closely, it's not that easy to find its scale factor. So I'm just going to set up a fraction. So let's just say, I'm not going to follow this. I'm just going to take both sides from the smaller triangle, which is 10 over 18. I would set it equal to same side, same corresponding side from the bigger triangle, which is 99 over x. Now next, I would just do cross product, so 10 times x, and it's equal to 99. Wait a second, did I do it right? So 10, oh, my bad. I set it up other way around on the other side, my bad. My mistake. I have to erase this now. My mistake. So my bad, I'll go back. So I would do 18 over 10, and it would be 99 over x. So cross product, it's going to be 18x is equal to 990, and at the end, x would be equal to 55. So that's how we solve for these missing side lengths. So pretty much that's all for today, and yeah, so that's all. Thank you.